So this is my second time attempting this video. First time I recorded this, the sound did not record. So hopefully that doesn't happen again today. I would not like to have to record this video for a third time. So we're going to go through right now and take some notes on this handout about how to write a very specific quadratic function. Unlike the warm-up that you guys got to do the other day, you cannot make up your own a values. So we have to calculate the exact a value that we want for this function. We can't make up our own. This video I'm going to use both with the honors and the level 1 class. So the honors class, this is a 5-day section, so 5 days from now you guys will have the end of unit exam, and then the level 1 you guys will have the exam in 6 days for the end unit. But you will also have the post-test in 4 days. So level 1, you guys will have the unit 2 post-test on day 4 of this section and the open-ended on day 6 with some extra practice in between. And honors, you guys will have just the open-ended on day 5 because your post-test was embedded in a lot of your other assignments. So let's go ahead and talk about how we write a quadratic function using given information. If we look at example number 1, we are given the vertex and a point. So right there, that should be a hint. If I'm giving you the vertex, we're going to try to write an equation in vertex form. So I'm just writing down what vertex form is so we can remember that and keep it in mind. What we will do then is take all of our known information, sub it into that formula, and solve for what we don't know. The vertex is h and k. The point is a random x and y coordinate, so what we don't know is the a value. We have to solve for a. In for y, we're going to sub in the 5 from our point. We don't know a. X is going to be the 4 from the ordered pair, minus our h value of 6. This is then squared, and we have plus our k value of 1. We've got to simplify this down and isolate a to figure out what it equals. I'm going to subtract the 1 to the other side, and also simplify inside those parentheses. 4 minus 6 is negative 2 squared. When you square the negative 2, it will become positive 4. Instead of writing a times 4, I'm going to write 4a. Then if you divide both sides by 4, you will see that our a value is equal to 1. Once you have the a value of 1, we just sub in the a, h, and k values into our formula to get y equals an a value of 1, which you don't have to write, x minus the h value squared plus the k value. And there's our function. So we just solved for the exact a value using the information given to us. In number 2, we are given x-intercepts. So we're not going to do vertex form. X-intercepts are easily connected with intercept form or factored form. So think of those like the P and the Q in our intercept notation. Okay. If you can recall in the solving unit, the relationship between factors and the x-intercepts, the signs are different. So same thing will happen here. When you have an x-intercept of negative 4, it's going to be plus 4 in the formula. And the 1, 20 will be your x and y that we'll sub in. So for y, we're going to sub in 20. We don't know the a value. X, we're subbing in 1 from our point, minus the first x-intercept. When you minus negative 4, that becomes plus 4. X value is still 1. That can't change. And we're going to minus the second x-intercept of 3. So minus 3 stays a minus 3 because the 3 was not negative. We're going to simplify inside each of those parentheses. 20 is equal to a times 5 times negative 2. We're going to multiply the 5 and the negative 2. 20 will equal negative 10a. And if we divide both sides by negative 10, our a value will be negative 2. Once we've got our a value, we again sub everything in to their intercept form formula to get our function. Y will equal negative 2, parentheses, x plus 4, because the x-intercept was negative 4, and x minus 3, because the x-intercept was positive 3. And that's all there really is to it. We're not going to be writing anything directly into standard form that requires a process of solving a system of three variables with three equations, which we have not learned this year and will not learn this year, something that you will learn in pre-calculus. So instead, we're going to focus on going into vertex form or intercept form depending on the given info. If we want standard form, we have to do intercept or vertex form first, and then we could distribute it and combine like terms to get it into standard form and rewrite it. Number 3, I'm going to have you guys try on your own. So pause here and give it a shot. I'm going to do vertex form because I have given you the vertex. So vertex is H and K, and the point is your X and your Y. So the Y goes in, we don't know A. The X is 0. When you minus H, when you minus -1, it'll become plus 1 squared, and then plus our K value of -4. I'm going to add the 4 over to the other side and get 1 equals A. Also combine in my parentheses to get 1 squared. When you square 1, you get 1, and a coefficient of 1 you don't have to divide by. So you're just going to get A equals 1. Therefore, my equation is Y equals an A value of 1, X minus H. So again, X minus -1 becomes plus 1 squared, plus my K. The last two on this page are going to be the same skills, but we have to take the information from a graph versus listed information. So looking at number 4, what I would want you guys to notice is that the vertex has been identified already for us, and a point, multiple points have been identified for us. Sometimes the points aren't going to be identified and you have to label them yourself, but still look for vertex and a point or x-intercepts and a point. So my vertex is -5, 7. There's my H and my K. And you could use any other point on the parabola you wanted. This one. You could also have done ones that weren't identified for you. So that's 4 points right there to choose from. I'm just going to use the point -4, 5. Once you pull the information from the graph, it's just like above. Go ahead and hit pause, give it another try on your own, and check your answer with my answer. Okay, I'm going to sub in my Y value. We don't know A. My X value, when I minus -5, it becomes plus 5 squared plus K. Subtract over the 7. 5 minus 7 is -2. Combine in the parentheses to get 1. And again, when you square 1, it's just a 1A. So A is equal to -2. And my function will be -2 x plus 5 squared plus 7. You could not have done intercept form on this one. If you look where the graph crosses the x-axis, they almost look like whole numbers, but they're not. They're decimals. And I don't want you to estimate, so we would not use intercept form. Number 5, you can see that the x-intercepts are clearly identifiable. I'm going to list those and use some different vocab right now. Our zeros are -2 and +3. And then another point, which one has been identified for us, but that won't always happen. Our point that we're going to use is 2, -4. On this graph, you will see that the vertex is not a nice whole integer numbers, so we can't use the vertex form. We have to use the intercept form. Sub everything in, sub in the Y. We don't know A. X minus the first x-intercept. So when you minus the -2, it'll become +2. And then x minus the other x-intercept of 3. And get -4 equals A times 4 times -1. -4 will equal -4 times A when you multiply on the right. And when you divide both sides by -4, the A value equals +1. Sub everything in. A value of 1 you don't have to write. X minus the first 0 becomes x plus 2 because it was a -0. And x minus the second 0 is x minus 3. You guys will get some practice on this on the homework, and we are also going to apply it to some real world on the back. So if you guys flip over there, I'm just going to pause this recording super quick, and I will be right back. I just need to check something. So if you flip over to the back, honors, you guys have this top example, and level 1 you don't. So level 1, you guys can fast forward a little bit to the next problem. But honors, go ahead and listen to my explanation on this doggy trying to get a treat. So it says Sasha is training her dog Bingo to run across an arched ramp, which is in the shape of a parabola. To help Bingo get across the ramp, Sasha places a treat on the ground where the arched ramp begins and one at the top. The tree at the top is at a horizontal distance of 2 feet from the first tree, and Bingo is 6 feet above the ground when he reaches the top of the ramp. We're going to write a function to represent Bingo's height above the ground as he walks across the ramp in terms of his distance from the beginning. So I'm going to draw a sketch so you guys get a better visual of what's happening. So imagine kind of like a skateboarding ramp, okay, where the doggy's down here. Here's a doggy. Looks like a bear. Okay, he's going to climb up the ramp to get the tree at the top. Okay? So where he starts, think of that like the origin, 0, 0. Where the treat is, it told us it's at a horizontal distance of 2 feet. And when he gets up there, he's 6 feet above the ground. So that's at a point of 2, 6. The 0, 0 is our vertex, where the arched ramp begins. So that's our h and our k, and where the treat is our x and our y. So we have enough information to go ahead and write the equation in vertex form. So we will sub in the y, we don't know a, we'll sub in the x minus the h plus the k. Zeros are nice and easy to work with. We're going to get 6 equals a times 2 squared. 6 will equal 4a, and if we divide both sides by 4, a will equal 3 over 2, if you simplify 6/4. Therefore, our function for little Bingo here trying to get his treat is going to be y equals 3/2 x minus 0 squared plus 0. You could leave it like that, but you could also just not write the zeros to get y equals 3/2 x squared. And that's technically standard form because h and k was 0. And then the last example, so this is an example that both the honors and the level 1 class are going to be expected to do. I'm just going to clear this out. So let's read it. It says Joshua shoots a basketball from an initial height of 6 feet. The basketball reaches its maximum height of 30 feet after it has traveled a distance of 40 feet. So we're going to write a quadratic function to represent the height as a function of its distance. So distance is x and height is y. So we do have enough information to write an equation. The fact that it uses the word maximum means we have the vertex. However, the vertex is not 30, 40. Just because the 30 is written first doesn't mean that goes first in the ordered pair. Because that 30 is the max height, which is a y value of the vertex. The 30 should come second. The distance, when it reached the max height, which was 40, should come first. However, to write an equation, we still need a point because we don't know our a value. The point is going to come from the fact that the initial height was 6 feet of the basketball. That you can think of like your y-intercept, and your y-intercept would have a distance of 0 and a height of 6, your initial height. Now we can use this information to sub everything in and get our function. So we're subbing in our y, we don't know a, subbing in our x minus our h squared plus k. We're using vertex form because we have the vertex. If I subtract over the 30, 6 minus 30 is negative 24 equals a times negative 40 squared. I'm going to jump up here to finish the work. I'm going to square the 40. Negative 24 is going to equal to 1600 times a. And then we're going to divide both sides by 1600 and simplify that fraction. So divide by 1600, divide by 1600. 8 is going to go into both of these, okay, which you could figure out on the calculator or using your head. When you divide 1600 by 8 and negative 24 by 8, you're going to get negative 3 over 200. So our function is y equals negative 3 over 200, x minus 40 squared plus 30. Now that we have our model, we can answer our follow-up question in part B. It says determine the height of the basketball if it's traveled a distance of 60 feet. Distance is important there. That means that value is an x value, not a y value. It's distance. So we're going to sub it in for x. Y will equal negative 3 over 200, 60 minus 40 squared, plus 30. I'm going to combine the inside my parentheses to get 20 squared plus 30. I'm going to jump up here, get a little more room, square the 20. To get 400, which I'm also going to place over 1 because the 3 over 200 was a fraction, plus 30. You have two options. You can just multiply straight across 3 times 400 and 200 times 1 and then simplify, or you could technically cross cancel. If I look at the 200 and 400, which are diagonal from there, you can cross cancel. The 200 would cancel out, and 200 goes into 400 2 times, which will leave you with negative 3 times 2, which is negative 6, plus 30. So y will equal 24 feet. Okay, that is our height of the basketball when it's at a distance of 40 feet, or not 40 feet, 60 feet. Again, if you don't get that idea of cross-canceling, you can do 3 times 400, which is 1200, and then divide that by 200 to get 6 still, so negative 6. Okay, so that is it for today's lesson. You guys might have a little bit of time in class to start the homework. Also, if the Type 3 copies are made and you want to get a head start on the Type 3, you guys could also ask for that a little early to work on tonight as well. Tomorrow you guys will get to practice this on that Type 3 and get ready for our upcoming tests. So remember, this was day 1 of this lesson. Honors, your test is on day 5, and level 1, your test is on day 6, but you also have the multiple choice post-test on day 4. I know that sounds confusing, but hopefully you guys are following what I'm saying. And that's it for today.